Okay, so today is the day two for business intelligence. Last we have covered BI part one. So if there is any step point, I think most of the people you are not there at that time. So please check the recording for the day one because for BI we have only two sessions. So today is the second session. The last day, just a quick recap what we have covered. So last day in the BI, we just learned what is the BI actually. I mean, BI business intelligence cycle, how we are taking data out. We means the data engineers. We are pulling the data from the source system. It's a OLTP system, and we are cleaning it. We are transforming the data, and we are loading the data into data warehouse. After loading everything in data warehouse, we are analyzes the data. So it's called data analytics. In the data warehouse, we can also segregate the data into data marts, and the data marts, even the data scientist can work on top of data mart, using those data. And the visualization team, they have also has the access on the data mart. On top of data mart data, they are creating the dashboard, visualization dashboard. Okay. But in the visualization dashboard, there are various charts and graphs based on the business criteria or business requirement. By checking those business charts and graphs, the decision owner or the business owner, they can take the decisions for the next day's business, what to change, what to plan for their strategy and all. So they can take the strategy and the same thing should be repeated, and they can find the new thing should be coming into the next is when the implementation of the strategy is been completed. So that is the entire cycle. Okay. And that we have learned with a very brief manner. And we have ended the things in the data mart. We are storing the data into fact and dimension table. I told this thing earlier. Just I'm repeating these things today once more time. What is fact and what is dimension? Then today's topic will be starting. So let me repeat once more time. What is fact and what is dimension? Actually, I mentioned while storing the data in data marts, the tables can be fact table or the table can be a dimension table. The fact table should be consisting of fact data and the dimension table should be consisting of dimension data. Now, what is fact data? Fact should be numerical in nature generally. Facts answer the questions. It can answer the questions of how much or how many. So just like my next slide, you can see those kind of revenue, cost, how many number of accounts are involved there. So this kind of informations are called fact information. It can also called measures. That we are measuring. That is called fact. Okay. So in the fact table, we are loading all those fact related information. You can see those things are red color highlighted one. Okay. So those are called fact information. And apart from that, the black color highlighted one, those are the foreign keys. Those are the primary key of each of the dimension table. We are keeping this foreign key because when creating the OLAP system, we can join between fact and various dimension to set up the data modeling. Okay. So the black color things, those are foreign keys. Each of the foreign key are is the primary key of another dimension. Let me show you. Coming to dimension first. Dimensions answer the question who, what, when, where, those kind of stuffs. And those are the general dimension. That should be the common dimension for each of the projects, just like customer, time, geography, employee. Those are different dimension. So here is a example of how dimension look like. This is dimension table. Store can be a dimension table. Product can be a dimension table. So in store table, you can see store key is the primary key. And apart from that, all the dimension related information in the store key, where is the store located, particular name of the store, which city it's there, which state, region, country. For product key, product ID, product name, product group, brand, department, everything is related to dimension, not related to measures. So when our fact and dimensions are ready, you can see just before in the fact slide, when we are learning fact, there we can see this kind of foreign keys are present. Stored key is the primary key over here in stored table, but it should be a foreign key in the fact table that I mentioned earlier. Okay, you can see stored key is a foreign key in the fact table. There is not only one foreign key, there is date key, stored key, product key. Those are called foreign key. So for in our foreign key, and this primary key is located in dimension. So before moving ahead with the reporting side, that means the visualization side, we can set up this kind of data modeling. Let me show you the data modeling first, then I can come up again. So this should be the data modeling, which is very much important. You can see there is a single fact table over here. Generally, we have single or very less number of fact table in our data modeling and various dimension table. Based on if each of the subject area, the dimensions can be segregated. This is product related dimension. This is customer dimension. This is time dimension, store dimension, clerk dimension, promo dimension. So each of the dimension you can see a primary key is there. Okay. And the same primary key is present over here as a foreign key so that I can set relationship between fact and dimension. Okay. The same thing is there for each and every dimension. And in the fact table, we have those foreign key at the beginning. When the foreign key is completed, then we are putting the original fact data. So basically when creating the data mart, in the data mart tables, we are segregating the tabular data such a way that it can be either fact table or it can be a dimension table. So when our facts and dimensions are ready, we can set up this kind of relationship. Maybe this is join, what we have learned in SQL join. So we'll be setting up join. There we need to keeping in mind the cardinality between each of the table. Cardinality means the relationship, maybe one-to-one relationship, maybe one-to-many relationship, or many-to-one relationship. This is called cardinality. Based on that, we have to do, is it left join, right join, inner join, this kind of stuffs that can be, that should be done. So while doing the data modeling, it should be also, we should have to think about that stuffs. Okay, I found some chat over here. It is not audible for everyone. Hi, Hartika. Haritha, sorry.
Yeah, clearly audible.
Uh, okay, I'm not able to hear you. Just give me 1 second. Anyone, Tanuja, is it audible? Supriya,
Oh,
anyone?
yeah, it is.
Haritha, maybe from your system some issue is there. Can you check your mic or any other thing? Or can you please rejoin if it is not audible properly? Okay, not sure. If there is any stuck point or anything, yeah, you can definitely stop me and ask me questions. Yeah, but I think I'm audible. If there is any issue or anything, you can please kindly rejoin. Okay. So the thing we are learning, it's data modeling part. As I was mentioning, when our fact and dimension is ready, multiple dimensions and a single fact, or maybe a less number. I mean, fact should be very less number. Maybe one or two, three fact tables should be there in a live project, and lots of dimensions should be there. So when all those things are ready, we can create this kind of data modeling. This is called data modeling. Okay. So after setting up the data modeling, now our data mart is ready for OLAP analysis. I mentioned what is OLAP in the last working day. So it's just like online analytical processing. So that table or the data is ready to use for the reporting layer. Okay. So this is the main fundamental stuffs. Uh, I mentioned the thing that we are creating the, I mean, we are pulling the source systems data by ETL and pushing it to various data mart tables. We have to store the data mart tables in this manner, and that is our end goal before moving into the reporting tool. Okay. Now I'm just going at some more aspects of data modeling quickly. I skipped some slides there. It's generally the fundamental stuffs we need to require for designing some fact and dimensions. I'll be coming to the slides quickly. Just let me complete the data modeling steps. While creating the data modeling can be of two types. One is called star schema, another one is called snowflake schema. And this is a, I mean, this kind of questions should be coming. What is star schema? What is snowflake schema? And uh, why we should need to create. They can
Hi,
give you
if you
scenario.
started this session, I'm not sure if it's only for me or not. Your voice is not audible.
Yeah, Harita. Not sure. I mean, everyone can able to hear me. But okay. So if there is any stuck point, you did not get any particular slides or anything, then I will be repeating these things. We have started with BI day 2. Actually, Friday we have covered BI day 1. Harita, first of all, are you a new person? I mean, you are joining today over here as a new class. Is this your first class? Harita? If this is your first class, okay. So, yeah, so that thing is recorded as well. So I'll be providing the same thing to one of the admin team members. You can get the recordings from there if you are missing anything. But if the thing is not understandable, please tell me. So I'll be trying to cover it once more time over here. Any particular slide or anything. Okay. Okay. What we are learning there, we are learning data modeling, star schema, snowflake schema. What is star schema now? Star schema should be looking like in this manner. Let me show you the diagram. In the star schema, you can see there is a single fact table and multiple dimension. It should be looking like a star only. Okay. So you can see the central fact table is there. It's a single fact table and multiple dimensions are surrounding it over here. Okay, just like a sales is a fact table, we have various, just like store key, time key, customer store dimension table, time dimension table, customer dimension table, product dimension table, payment type dimension table. So star schema, it's one of the data modeling approach and is the easiest approach when we have very simple or fundamental data with us. We need to create the data model in this manner. Then we can create star schema. But in the practical scenario, we have lots of dimensions we need to take into consideration for complex logic. So there, star schema is not only the only way for designing or developing the data modeling stuffs. There we need to think about Snowflake schema. What is it actually? It is also having a fact table over there. Dimensions tables are also there, but all the dimensions are not directly tagged with fact table. That means you can see over here the brand category, those dimensions tables are directly not having the relation with the fact table. Rather, the product table is not normalized in nature. Okay. So we are creating some normalized table over here, just like product brand, product category. So those are directly tagged with or directly have the relation with product. Brand is having direct relationship with product. Category table is having direct relationship with brand. So we are setting relationship between fact and dimension by this link, not individual fact to dimension link. Maybe this is the reason we are unable to generate foreign key in the fact table. That can be a complex one. Okay. Or maybe this is that particular join is very much easier than that particular things to be done from the fact side, we can directly do from the dimension side. So this kind of data modeling is called Snowflake. Over here, if you can remember at the second day of the class, there we have mentioned what is normalized data, what is denormalized data. So over here, product table, maybe it's not highly normalized there. So this is one of the concept we are doing the thing over here. So brand is not directly having a relationship between the main booked orders fact table. Rather, we are keeping relationship with this. So there may be a foreign key in the product table to join with brand table. And we are keeping all the data from this brand over here. And then we are joining with fact table. So this is the concept. It's working over here. Okay. So any doubt till now in the data modeling section? Actually, data modeling is very, very important steps. If you are a good data analyst, data analyst, first of all, as an architect or as a good data analyst, you need to think about what should be the data modeling first. So when your data modeling is ready, then your concept should be clear. What should be your data mart tables? What should be the DDL? DDLs means what columns need to used for creating those fact and dimension tables. So create the data modeling first. It's a top-down approach based on the project scenario. What kind of columns I need require for a quick analysis or to get the hidden pattern. What are the different columns I need, and they are setting the relationship between by this data modeling. And when our data modeling is finalized, then we can have a clear picture how the data mart should be looking like. Over here, just like in the data mart, we need to create one fact table that is called booked orders and multiple dimension tables called customers, organization, time, geography, product, brand, category. This is the thing. And what should be different columns name and their data type, their sizes as well. We can easily determine from this data modeling, and we are free to create the data mart tables into databases. Okay, similar kind of stuffs. How we have created the tables in earlier exercises or earlier chapters in SQL. Okay. Okay, moving to the next slide. Okay, it's ETL. So I'll not be going to ETL now. Let me complete the previous stuffs. I have skipped some of the slides after learning fact and dimension. Let me cover this thing. Okay, so I'll be coming from this thing again. I'll be reorganize some of the slides in the previous session, but just to show you how the things are coming one by one with sequential manner. So that is why after creation of fact and dimension, how it should be looking and what is the application of it. To show this thing, I just showed you what is data modeling. Why we are keeping those primary keys and foreign keys in dimension table and fact tables respectively. So this is the main reason behind that. Okay, now some terminologies I have just kept that time. So just have a quick concept on top of that. That should be helpful for you for, I mean, in future, maybe your user or business user or your architect can tell you that this should be the grain of your particular fact table. Okay, they can mention you. This should be the grain of your particular fact table, but you are not able to understanding what is grain. So this is the fundamental things or fundamental terminologies just to show you how it should be working to design a fact table or dimension table. So first of all, I'll be coming with grain and granularity. Those are two terminologies, especially it is involved with fact table. So while defining grain, grain is a business definition of a particular fact table. It defines the measurement event that produces the fact table's row. So while defining a single fact table row, how we should define it in a single line? That is called the grain of the fact table. So here is the fact table. Here we can see in the fact table, we can see sale ID is there, deal number is there, date column is there, item code is there, store ID is there, quantity is there, amount is there. Okay. So in the fact table, we can define each row by this line. Sales transaction per store, per item, per date in a bill. Okay, you can see a particular row can be represented by in a single line. Sales transaction per store, per store. There are lots of stores available. Something is Mumbai. A particular brand is having lots of stores in Mumbai, in Chennai, in Bangalore. So sales transaction per store, per date. Okay. Here it should be also mentioned per product. I have skipped it. So yeah, sales transaction per store, per okay, per product. Yeah, it's there per item. So sales transaction per store, per item, for a particular date. So it's per date in a bill. Okay. So this is called the grain of the fact table. So I'll be just mentioning once more time. It's another thing. It's a particular result of a particular student. I mean, for a particular school, a particular, you can see lots of batches are there. So their results have been captured. So how we can tell the grain? Grain is marks of a student got in a subject in a particular exam. Okay. So suppose we are uh, what I can say. If I just remove marks of a student got in a subject, we have removed the exam. That means exam column should not be introduced over here. That time, if the exam column is not there, we need to aggregate the things. So for the first student called Ayan Dev, if the subject is not there, exam is not there, so we can just for 9B batches, we can aggregate the things. Let me show you in a quick example. Suppose it was student, subject, marks, Exam. It was iron. Exam, it was half yearly. Subject, let me keep some subject history. Marks 75. Okay. So same iron is, I'm repeating once more time. It's mid-year and it's I can took annual science 88. Same iron again. So okay, let me put something. Okay, suppose this is the marks, or we can say this the grain of this fact table. This is a fact table, obviously. We're having the fact data over here. So you can tell over here the particular fact table is having the information, particular student. Okay, marks of individual subject for individual exam for a particular student. Suppose I want to remove one grain. Okay, suppose I need to remove subject. Okay, if I remove subject, so what should be happening? I'm just removing it. Then this particular column annual is mentioned twice. So just think about it. We have one row called iron annual 88, iron annual 72. This is not a good thing. If we remove the particular column, we need to merge these two rows. We need to have a group by and we need to sum it up. Okay, so it should be something iron and annual should be removed. I need to add 72 with 88. Okay, so when we are changing the grain of a particular fact table, a particular thing is also getting impacted. That is called granularity. I'll be coming what is granularity now. So this is called grain. How grain should be taking into picture. This is the thing. Okay, grain means a particular row, how it's been representing the entire fact table's nature. Now, what is granular? Granular means how detailing we are providing the data into the fact table. The same thing I have mentioned over here. Just we mentioned in the example. Over here, we can make it more details. If we are detailing it, means we are introducing number of we are introducing number of columns as well as number of rows. Suppose uh, I am just introducing one more columns to make it more granular. Let me show you. But that much granular is not required for a particular exam sheet. Suppose I'm just section. Which section, which mark should be, how many marks they are receiving. So for half yearly history, introducing MCQ questions. Okay, so for this row, let me just split it up. Broad question or short question. So at first it was 75. Let me just put 20, 20, 40, 35. So if we just, I'm just going into more dipping, I'm dipping dive the analysis part. Then I need to go to the particular transaction with more granular level. So I have introduced a new column. It's called section. If we need to fill up the section, we can see the marks are being splitted again. The facts are getting splitted because we are going ahead with more granularity. That is called granularity. If you are just going ahead with more granular, the grain is also modifying. For this fact table now, we can say the grain is marks per section per subject per exam for a particular student. Section has been introduced over here. Okay, but we need to think about the requirement whether this much of granularity is really required for a fact table or not. Okay, and if we just want to remove any columns, it will be less granular. Less number of rows should be there because the rows should be grouping by. The aggregation should be there on top of fact data. Okay, the concept is clear to everyone. Sanuja, Sudhir, the
Oh,
concept of,
yes.
okay, concept of grain, what is granularity? This is the main concept. So let me just go to the slides again. What is granularity? Okay, grain we just covered up. For to define a particular fact table, we need to define a particular row that is called grain. Now granularity refers to the level of detail of data stored in fact table in a data warehouse or in a data mart, rather we can say. High granularity refers to the data that is at or near the transaction level. Data that is at transaction level is usually referred as atomic level data. Okay. So near transaction level, it's called atomic data. Low granularity refers to data that is summarized or aggregated. Low granularity means we have less number of rows because those are summarized or aggregated. That's just I mentioned. Okay, and atomic level data means we have as much minute data we are trying to fill it up, then that is called atomic level data. The granularity is at atomic level. Okay, now I'll be just going to give you some concept on top of dimension. Now just think about it. We have fact table, we have dimension table. Let me open a data model. Yes, this one again. So we have fact table, we have dimension table. Suppose we have the dimension table, it's called store dimension. I am the owner of a particular brand and I have multiple store outlets. In the dimensional tables, you can just look like the column. The dimension data is not changing daily basis because today I have 7 outlets for the entire country. In the entire country, in the metro cities as well as some other cities, I have total 7 outlets. For each of the outlets, I'm just putting the information. Maybe I have 12 outlets. Maybe I have 20 outlets. Okay. So daily basis, I'm not creating a new outlet there. So in the outlet, we have store key, store name, address. So today the data is fixed. Tomorrow I'll not be going to create a new data for this because outlet will not be creating daily basis. So dimensions are really very slowly changing in nature. The time, the clerk, the promotion dimension, customer dimension. Yeah, customer, we have new customers daily basis. There is no issue. But the changing of dimension is comparatively very less than that of fact. Because in fact, we have transactional data. We have each transactions are being saved in fact. Okay, we have, you can see dollars sold, units sold, dollars cost. So those kind of information we need to capture. Each day's transaction we have to store in fact table only. So fact table is changing very much faster. So today we have some data, tomorrow I can see the data difference in the fact tables is nearly more than thousands. Nearly it can be a millions data. We have daily basis transaction. Okay, in a particular fact table. But dimension tables are very slow changing comparing to fact table. Now, while storing the data into dimension, we are following three particular type. One is called ACD type 1, ACD type 2, and another one is called ACD type 3. ACD type 1, ACD means slowly changing dimension. In slowly changing dimension type 1, type 2, type 3, let me show you how it should looks like. I have an example over here with myself, ACD example. Okay, so that I mentioned, SCD is especially for how we are storing data in dimension, how the data should be looking like, or what is the loading strategy. So it's the most fundamental one, type 1. So suppose I have kept the employee related information as an example over here. So in an employee table, employee ID should be there, employee name should be there, and employee designation should be there. Suppose one particular employee, let's say employee number 1, he has joined the company as trainee. Till yesterday, the data load by ETL is over. We can see at the target system that particular employee, there his designation is trainee. Okay. Tomorrow, the particular employee's designation is updated at the source system and the same is captured at our target data mart. So the particular employee has been updated to developer. And a new employee has also been introduced in today's data load. Okay, yesterday it was trainee, and today we can able to see that the particular data has been updated from trainee to developer. And a new row is also been introduced for a new resource. A new resource has joined as trainee level. So you can see the particular new thing has been appeared. So these two changes I have found from previous day to today, but the other rows are same. You can see these three rows are same. There is no issue. Okay, that is fine. In ACD type 1, we are not mentioning any history data. So if anyone is checking today's data, there is no clue what particular date that particular employee has been promoted from trainee to developer, or whether that particular employee has joined the company as trainee, later he moved to developer, or the particular employee has joined the switched from a company to developer role, the current company. We do not have this answer over here. Okay. So ACD type 1, the main things, we are not keeping any history. So that is why ACD type 2 is required. So it's another way to loading the dimension. Maybe there is a requirement that you do not have to keep history in which particular date the particular column is getting updated, a particular data is getting updated. It's not required. Then ACD type 1 is fine for your project purpose. But in your project, you need to keep that particular information too. If this is the requirement, then we need to introduce a new column called date, or maybe transition date. Okay. So maybe I'm keeping the last transition date in that particular column so that we have the idea that the particular employee is having what is the previous designation and when he or she got promoted. Just like with the same example, he was trainee on 23rd. He was also trainee over here. No, yes, in the next column, I'm modifying it. So this column is there. Sorry, this row is there already. I'm keeping another row saying one ABC. The designation has been updated to developer with the transition date. Okay. So this kind of data storing methodology in Dimension is called SCD type 2. We have some reference column to maintain the history. Just like over here, it's the transition date or transition date, anything over here. Okay. Now what is SCD type 3? Over here, we are introducing one more column so that we can get rid of this extra row. We are just introducing a new column called previous designation. Okay. So just like if any transition happens for a particular day, that day is been captured and I am mentioning what is the previous designation. I kept it twice. Yes. So SCD type 3, you can see rather increasing the number of rows, we have increased one more column and we are keeping the data in this manner. One ABC developer, his current designation is developer, particular transition date, he is there as a developer role is this, and his previous designation is trainee. So both of the informations are kept in this manner. If we store the data, it's called type 3, SCD type 3, slowly changing dimension type 3. So this is the concept of storing data in dimension. It can be either in this three way. It's called SCD type 1, type 2, type 3. Okay. Any doubts still so far? Anyone is having any doubt till now? Okay. No doubt. Now moving to the next topic, data model we have covered already. Now we just covered up what is dimension, what is facts, some basic properties of fact and dimension. Now after when our fact and dimension as are ready, we can go ahead with the data modeling stuffs and all. Now the concept of ETL should be coming. ETL is a particular tool. I mentioned this thing in earlier block diagrams and all. So it is uses to load data from source to target. ETL means E means extract, T means transform, L means load. So we are extracting the data from the source system, we are transforming the data, and we are loading the data at the target. Okay, so this is the concept of ETL. So ETLs are running daily basis. Suppose we have new data coming to the source system today. We have to load the same at the target. Otherwise, we cannot create the data model. Or I mean, the data model is there. We should not having the updated information in the data model. We should not having the updated information in the data mart or data warehouse. So the new data are coming into the source system and ETL jobs are there. The jobs are running daily basis or maybe hourly basis based on the criticality of the data refresh. Okay. So based on the criticality of data refresh, ETL jobs are running and they are capturing the source systems information to the target side. So I'm repeating, ETL means extracting the information. So suppose this is the source system. This is our target data warehouse. We are extracting the information. Transforming means we are doing some cleansing operation, convert the data to a required format, or any business logic needs to be implemented there. Some joins, maybe some sorting things, some aggregations. Uh, so this kind of things, some by using some inbuilt function, we are just updating something. So all the transformation related stuff should be there. And when the data is ready at the transformation, then we are loading it at the data warehouse. Okay. Now the load strategy or the extract strategy can be of various way. Let me show you the things. So data extracting method, the thing can be full refresh or it can be incremental data load. Just think about that. Suppose we have data in the source system. So data has been updated. What the data was in yesterday, the data volume got updated today. So some extra records has been captured. So we have two data extract method. One is called full refresh, another one is called incremental. Full refresh means if we took all the data from source system to be pulled, because we need to push all the things at the target too. So that is called full refresh. If you take all the data from the source system and pushing everything to target, this is called full refresh data extracting method. And another one way is incremental data load. That means we are not loading all the data daily basis. Suppose we have millions of records at the source systems. Today, some more 20,000 records got added there. So if we daily basis load this many records, it should take much more time, and we are loading the same record and some extra delta record daily basis. So if this is not a good approach, and if we are just checking the performance issue there, then we should not go ahead with the full refresh. Rather, we can go ahead with incremental data refresh. Okay. So whatever new records are there in the source system, we are just pushing the same thing at the target. We are not going ahead with the full data refresh from source to target. Okay. This is called full refresh extracting method. Okay, this is called incremental. Sorry, the first example that I showed you, it's called full refresh, and the second one that we mentioned, that is called incremental data load. What is the new data? That is called delta data load as well. What's the new data we are receiving from the previous day's record? We are just keeping that particular thing. Just to give you an example in Excel. Suppose we have few records over here. We have suppose column 1, column 2, column 3. Those are the main data columns. We are keeping some reference column called created date. This can be a metadata column for that table. Create date means a particular row is being created for which date timestamp. Okay. So that particular column will capture the particular records information. It's a metadata of that particular columns. Suppose this column has been created, this rows has been created in a particular date, maybe 10th July 2023, maybe at a particular time, 10 p.m. 10 p.m. a particular time, suppose EST. Okay. Now our ETL jobs, when it's running, it is capturing, when it's running, it's capturing the create date timestamp. Okay, so whatever last data or last row it's picking up in the job, it's storing the latest value of that particular column's data. So when the next day the job should running, it will check the stored value of this create that timestamp, and what is greater than that, it will check what are the new values or new columns are new rows are receiving after the previous date timestamp. It will only load this data only. So that is the method of incremental data load. To do the incremental data load, there should be some create timestamp or update timestamp or some incremental column indicator or any kind of such metadata column should be referred there. On based on that, the ETL job can easily understandable what are the new records to be loaded. Okay, and they are able to do the incremental data load by this manner. Concept is clear to everyone? Actually, business intelligence and I mean, these 2 days, it's a bit conceptual, rather technical. So if the concept is not clear for data extracting, please tell me. Okay, I hope everything is clear. So when the data extracting is completed, I'll be going ahead with data loading. So while loading the data from source to target, there is also some strategy. So if we are just going ahead with full refresh, that means entire data from source system to target, then we need to load data in truncate load method, because we are loading all the data from source to target. Then we need to truncate the target table first. That means truncate command we need to execute. Truncate table name. Our table should be empty first, and then we can have a full refresh. That means the entire data from the source system can be pushed to target. Okay, it's called the truncate load method. There is another two method I have mentioned, insert. So it's generally insert and upsert, update and insert. It's also called upsert, the last one. Okay, so insert is also called append. So whatever new records are coming at the source system, we are directly appending it. So it's for incremental data load or incremental data extracting method, we can go ahead with either insert or upsert. Insert means at the target side, we are just appending it. And update insert or upsert means we are updating existing records, okay, and inserting new records by the particular at the above mentioned source system. If we are having incremental strategy, data load strategy over there, if we want to update the data from the source, I mean, at the target system, what are the new records? If this is new records, we definitely have to append. Suppose based on a primary key, we can see a particular column has been updated. Then we need to update it. Let me show you one more thing. So update, insert, those kind of stuffs can be based on a primary column. Okay, suppose this is our primary key or primary column. Maybe it's an employee ID. The same example I have showed you. Okay, suppose I am in SCD type 1. So while loading the loading the thing, yesterday the data is having in this manner, and today I found this is our primary key. Employee ID is the primary key. Today we found two records. One is this one, another one is this one. So based on the primary key, we can determine whether it's a new record or whether it's an updated record. So employee ID 1, I can see this particular data is an updated one. One is already existed in the table, but employee designation has been updated from trainee to developer. Okay. So we need to go ahead with update first. So whatever existing record was there, I need to update it. And for the data which are coming new, it should be loaded as the new insert method. So the entire method is called update and insert. What is the old record? It should be updated. What is the existing record? I mean, what is the new record? That should be inserted. And the system will determine this based on the primary key. Okay. That is called update insert. So there is any stuck point from anyone till now? If there is anything, any issue, actually maybe the concept is not clear to everyone. It is a bit, uh, I mean, complex topic, but this is required for a data engineers actually. It's an, I mean, it's theoretical topic. You can see we are not going ahead with technical stuffs as of now on top of these topics. But any doubt or any stuck point, if it is there, please try to, try to say over here so that we can try to explain the same thing. Okay, I'll be covering one more slide, and the rest of the slide I'll be covering tomorrow. So just like we have covered the ETL part, there are various ETL tools are available in the market for this kind of, data loading strategy. So just like Informatica, those are the different product vendor, and those are candidate products. So there is Informatica is one of the important ETL tool available in the market. Power Center is the candidate product. So similar kind of, there is IBM data stage is there, Ab Initio. For SAP there is another ETL tool is there, Cognos decision stream is there, Cognos data manager was there. Okay. For Microsoft SSIS SQL Server is, integration service. Okay, this kind of ETL tools are available in the market. Each of your project can take any one of the ETL tool to load the data from the source to target. Now onwards, few of them, not few, many of the projects they are using some language based framework driven ETL tool. They're creating the ETL tool by their own. They're using Python and they're creating some framework as an ETL tool. Why they're using this kind of stuffs? Because those kind of ready-made ETL products, those are, having high licensing cost there. Okay. And the companies are purchasing those products for their ETL tool, with some prices and all. And they have to buy the license and all. The license can be renewed maybe after 6 months or after 1 year, this kind of stuff. So, but the tools are very much faster. That is one of the main thing. We are loading data from source to target. The tools are loading data very much faster. So that's why based on totally company's requirement, either companies are acquiring some tools, okay, or they are using some language driven framework to load data from source to target. So those are the ETL concepts. So we will be taking Python. When we will be learning Python, at the end of Python, we will be learning how Python can be used as an ETL tool there. We will be taking an example. We will be pulling some data from the source system and pushing it to target by Python language. We'll be learning that stuffs when learning Python stuffs. So today I'll be covering till this ETL topic, and the visualization topic. I have few slides. I'll be just explaining that thing tomorrow. And tomorrow I'll be also starting Python for day one. Okay. Okay. Any doubt from anyone till now what we have covered? If there is any, please try to tell. Okay. As there is no response, I hope no doubts. So let's connect tomorrow with having, resuming from this topic. We have covered till ETL. Next day, how when the data mart is ready, then we have to go ahead with the reporting part. A basic concept on reporting side, I'll be just providing to you so that you have the overall picture what the data engineer can do from source to target. The overall picture so that you can also choose your career. If you are just going to start your career, maybe you can be an ETL developer, you can be a visualization just like reporting tools developer, anything you can choose. You can be a data analytics. Okay. Okay, let's connect tomorrow with the rest of the topics. What we are, we are able to, what is left for today, we'll be covering tomorrow, and if possible, we can also start with Python day one. Okay, that's all for today. Thanks, everyone. Bye bye.
Thank you. Bye.
Thank you.
Thanks. Bye bye.
Thank you.